Hello everyone. Today we will be discussing the quick solutions of All India AIATS Test Series JEE Main Test 4 Code A and B Mathematics, which was held on 2nd December 2018. So let us start with the question number 61, that is, if omega is a non-real cube root of unity, then the value of sine summation of r going from 1 to 6 r minus omega into r minus omega square into pi upon 708 is, right? So firstly, let us find the value of summation r going from 1 to 6 multiplying r minus omega and r minus omega square. We get r square minus r, taking common we will get omega plus omega square, that is minus 1. So it can directly be written as plus r plus omega cube, that is 1, right? Now this can further be written equal to, we know the summation of r square, that is r into r plus 1 into 2r plus 1 upon 6 plus summation of r from 1 to 6 will be equal to 6 into 6 plus 1 upon 2 plus 6. So this will be equal to 91 plus 21 plus 6, which is equal to 27 plus 91, that is 118, right? So the value can be written equal to sine of 118 into pi upon 708, right? So this can further be written equal to sine of pi upon 6, that is it will be equal to sine of 30 degrees, that is 1 by 2. So the correct answer will be option number 3. Next is question number 62, that is, a complex number z satisfies the inequation mod z minus 1 less than equal to 7 and z1 is equal to 4 minus 3 iota, where iota is equal to root of minus 1, then the greatest value of modulus z minus z1 minus 1 is. Now to find the greatest value of z minus z1 minus 1. Here now, as we are given the value of modulus of z minus 1, so let us create that term over here, that is we will write it equal to z minus 1 minus z1, right? Now we know that modulus of z1 minus z2 is less than equal to modulus of z1 plus modulus of z2, right? So this can be written less than equal to modulus of z minus 1 plus modulus of z1, right? So it can further be written as less than equal to mod of z minus 1, as it is given to be less than equal to 7. So it will be written as 7 over here plus modulus of z1, that is 4 minus 3 iota, right? So this is less than equal to 7 plus 5, that is it is less than equal to 12. So the correct answer will be option number 3. Next is question number 63, that is, a complex number z equal to x plus iota y, where x comma y are real and iota is equal to under root of minus 1, satisfies the equation modulus of z plus 2 minus 6 iota plus modulus of z minus 6 plus 2 iota equal to 8 root 2, then the number of integral pairs satisfying the given equation is. So in this question it is given that, let us make the coordinate axis. This is x-axis and this is y-axis. So here it is given that distance of z from minus 2 plus 6 iota plus distance of z from 6 minus 2 iota is given to be equal to 8 root 2, that is minus 2 plus 6 iota and 6 minus 2. So let us say the line is something like this. So it is given over here that the distance of z from these 2 points is equal to 8 root 2. Let us say the points are A and B. Now let's find the distance AB, which will be equal to under root minus 2 minus 6 whole square, that is 8 whole square, plus 6 minus minus 2 whole square, that is again root of 64, which is equal to 8 root 2, right? Now the distance of any point Z from A plus the distance of Z from B is given to be equal to 8 root 2. So from here we can see that the locus of Z will be a line segment between AB, right? So to find the number of integral pairs x comma y, we can firstly find the equation of line AB, which will be equal to y minus y1 equal to m, that is 6 minus minus 2 upon minus 2 minus 6 into x plus 2, that is x plus y is equal to 4. This is the equation of the line, right? Now the points that will be lying between AB or on A and B are minus 2 comma 6, minus 1 comma 5, 0 comma 4, 1 comma 3, 2 comma 2, 3 comma 1, 4 comma 0, 5 comma minus 1 and 6 comma minus 2. So we have 9 integral points here, right? So the correct answer will be option number 2. Next is question number 64, that is the imaginary part of a complex number z satisfying the inequation z minus 16 iota less than equal to 8 and having the least positive argument is. Here also let's plot the locus of the complex number z. Let us say this is x and this is y. Now here the circle is given something like this, that is the center of the circle is 0, 16 and its radius is 8, right? So this point will be 0, 8 and this point will again be 0, 24. Now the imaginary part of complex number z is lying on this circle. Now we have to find that value of z for which it have least positive argument. So let us draw a line from here and let us join the center of the circle with this point. Let us say this is O, this is A and this is B. So the point B is what we have to find here, because B will be the point that will be having the minimum positive argument, right? So we have to find the y coordinate of the point B, right? Now here OB is given to be equal to 8 because it is the radius of the circle, right? And here the distance OA is equal to 16. So in right triangle OBA, we can find the value of AB, right? Now OA square will be equal to AB square plus OB square, right? Now OA square will be equal to 16 square is equal to AB square plus OB square, that is 8 whole square. Therefore AB will be equal to 8 root 3. Now we have to find this angle theta also. So firstly let's find this angle, that is 90 minus theta. In the same triangle OBA, we can see that sine of 90 minus theta will be equal to OB, that is 8 upon OA, that is 16. So this is equal to 1 by 2. That is cos theta is equal to 1 by 2. So we can say that angle theta is equal to 60 degrees. Now we can find the point B, that let us say it is Z, right? So we can find Z equal to magnitude of Z, that is AB, which is equal to 8 root 3 into cos theta plus iota into sine pi by 3. Now for Z we need only the imaginary part. So its imaginary part will be equal to 8 root 3 into sine of 60 degrees. That is root 3 by 2. So it will be equal to 12. So the correct answer will be option number 1. Now next is question number 65. That is, let alpha and beta be the roots of equation x square plus 2x plus 4 equal to 0. Then the value of alpha raised to the power 2n plus beta raised to the power 2n, where n belongs to natural number, is. Now here let us firstly find the roots of the equation, that is alpha comma beta, is equal to minus b plus minus under root d, that is b square minus 16 upon 2 into a, that is 2. So this is equal to minus 1 plus minus under root 4 minus 16, that will be minus 12, and dividing it by 4 we will get it equal to minus 3. That is, this is equal to minus 1 plus minus root 3 iota. So let us assume alpha equal to minus 1 plus root 3 iota, and let us say that beta is equal to minus 1 minus root 3 iota. So alpha can be written as magnitude of minus 1 plus root 3 iota, that is under root of 1 plus 3, that is under root of 4, that is 2 into. Now let's find the argument of this, as tan theta will be equal to root 3 upon 1, that is root 3. From here theta will be equal to pi by 3, right? But the point is lying in the second quadrant, therefore the argument will be pi minus theta, that is pi minus pi by 3, that is 2 pi by 3. So it can be written as cos of 2 pi by 3 plus iota into sine of 2 pi by 3. Similarly for beta, we can see that the point is lying in the third quadrant, as both x and y are negative. So its argument will be theta minus pi, so it can be written as cos of minus 2 pi by 3 minus iota into sine of 2 pi by 3. So to find the value of alpha raised to the power 2n plus beta raised to the power 2n, it will be equal to taking 2 raised to the power 2n common, and here by de Moivre's theorem we can bring 2n downwards. So it will be equal to cos of 2n into 2 pi by 3, and the term with sine 2 pi by 3 will get cancelled. So it will be equal to 2 times of this, which is equal to 2 raised to the power 2n plus 1 into cos of 4 pi n upon 3, right? So the correct answer will be option number 3.